the PE guy here. In this video we're going to be looking at complex numbers. Now it's a pretty fundamental topic in power systems. I'm expecting that you guys know the basics of complex numbers, and I'm just going to be doing a review here of complex numbers. So first, there's two forms of complex numbers. You have polar form and you have rectangular form. So first we're going to look at rectangular form. So in rectangular form you have C equals, C is your complex number, which is a vector, is A plus J B. This should be lowercase b, JB. So A is the length on the real axis, and B is the length on the imaginary axis. And when we graph complex numbers, we'll see this. And you're going to use this form if you want to add or subtract complex numbers and you're not using a calculator. Or if you're going to do, if you want to know what the apparent and reactive power is. But if you have the apparent power and you want to know what is the real power and the reactive power, well, it's best to convert to rectangular form, and then in that case A is going to be your real power and B is going to be your reactive power. So then the second form is we're going to have again our vector C. The second form is polar form. So there's two ways to write polar form. R is R e to the j theta. That's the first way, and then the second way is R angle theta. Now, when you're doing power systems problems, you will almost always see it in the second form, R angle theta. Now, R is the magnitude of C. So, and then theta is the angle of C. So when we graph it, we'll see this. So let's graph it. So when you graph, you have your real axis over here, and then you have your imaginary axis over here. So here we're gonna graph. So what we're gonna graph is S equals P plus JQ. So this is very useful, because when you want to know something about a load, this power triangle, this is what we're going to do, is called the power triangle, is going to be really useful. So the real component of this is P. That's the real power. So here we have P, and this is in kW. Okay, and then we're going to have the imaginary component, which is called Q, and this is in kVars. Okay, and then we're going to have the S is over here, and this is your apparent power, right? And this is going to be just in kVA. And then there's also this angle theta. So one thing to note is that S is also equal to the magnitude of S angle theta. So this length over here, let's do a different color. So this is like the magnitude of S, and then this is your angle theta of S. And then your P and Q, you see your P is, this is the length of P and the length of Q. Okay, so that's graphing, and we'll do another lecture, another video on more on how you use the power triangle to solve problems. So the next thing we're going to look at is how do you convert between rectangular and polar form. So let's say you have a C, and this C is in rectangular form. So you have A plus JB, and you want to know what is the polar form of this. Well, the polar form again is R angle theta. So first you need to figure out what's r. Well, r is just going to be the length of, well, let's go back to this triangle. So you want to find out what is this length? This is r, right? So what is this length? So how do you solve that? Well, just use, the square root of p squared plus q squared in this case. So over here we're going to do a squared plus b squared square root. So we're just finding the length of that. The next thing we got to know is what is theta. Well, theta, again, we got this triangle, right? And then we have a and b. Well, theta is going to be the inverse tangent of b over a, right? So that's how you're going to get theta. So now you got r and you got theta. Okay, so let's do the reverse. We got r is equal, so we got c is equal to r angle theta. So let's do this one here. So we got r and we got theta. So how can we find a and b? Well, see, a is the real part of c, right? And that's just r cosine of theta. And then b is the imaginary part of c, right? And that's just r sine of theta. So you can just use trigonometry to do this, to do these conversions. It's a good way to think about it, is just thinking about that triangle. So the next is going to be multiplying and dividing. Well, first let's do adding and subtracting, actually. So let's say you got C1 is equal to A1 plus JB1, and you got C2 is equal to A2 plus JB2. Well, C1 plus C2, we're just going to add the A's and we're going to add the B's. So A1 plus A2, right, plus J times B1 plus B2, not B squared, but B2. Okay, so just an important thing to note here is that you can't just add, if you know, like, if you knew the magnitude of C and the magnitude of C2, you can't just add them together, right? So, and where this comes into play is, like, if you knew S1 plus S2, right, you can't just add them together. You can't just add the magnitude of the apparent power together. You have to use this scalar, you have to use this addition over here. You have to do the power, you have to add the powers together, plus the real powers together, plus the reactive powers together, and then take that result and calculate the magnitude of that result if you wanted to know what was S1 plus S2. Right? So you can't just add, you can't just know that, oh, S1 is 100 MVA and S2 is also 100 MVA, so it's 200 MVA. That's not how it works. You got to find out what's your real, what's your imaginary for each for each S, and then add them together using this method. So you can't just add S1 and S2. This is kind of a, I think this is a common mistake, trying to just add the two MVAs together. That doesn't work. Okay, so the second thing we're going to look at here is multiplying and dividing. So in this case, you want to use R angle theta, R1 theta 1, and then C2 R2 theta 2. So C1 times C2, we're going to do R1 R2 angle theta 1 plus theta 2. So let's say you want to do C1 divided by C2. So this is R1 divided by R2 angle theta 1 minus theta 2. So that's how you do that. So then the next thing, okay, so that's adding and subtracting. The next thing we're going to look at is complex conjugates. So the conjugate of a complex number it's represented by an asterisk. And what you're basically doing is you're taking the imaginary part of this complex number and you're flipping its sign. So let's say that C is equal to R angle theta, right? And you want C complex conjugate. Well, what you would do is you would do R angle minus theta, right? So you would just basically flip the angle. Whatever the angle is, you would just take its negative of that angle. So now you have to note that not all angles are positive, right? You might have a C where that angle is minus 120. Well, when you flip it, it's going to be positive 120. So you're not just taking the negative. You got to make sure that you flip the sign if it's negative or if it's positive. And then the second way we can look at this is in rectangular form, right? So let's say you have a C A plus JB, right? And then you want to do C complex conjugate. Well, that's just going to be A minus JB. Now remember, like let's say you had your B was negative to begin with. Well, when you do its complex conjugate, it's going to be positive now. So that's just one thing to remember. Okay, so that's kind of it for complex numbers. The last thing we're going to look at is phasors. So when you have a voltage, let's take a voltage first. So when you have a voltage V of t, right, this equals Vm divided by, oh, sorry. So this is going to be Vm cosine omega t plus some phase angle theta. So this is the way you write a voltage, right? Well, if we want to express this as a phasor, we're going to need to convert it, right? So how do you convert it? Well, the way you convert it is you want to do V equals Vm, right? Vm is the maximum, the Vmax, right? The maximum this signal is going to get, right? So Vm, we're going to divide it by root 2, right? And then we're going to do angle theta. So that's how you would write this in this in its phasor form. And once you have this phasor form of your voltage, now you can use it in equations, right? You can do V equals Iz, you can do S equals Vi complex conjugate, right? So this makes it much easier to solve these problems. So you might be wondering, where does this root 2 come from? Right? You might wonder, where does this root 2 come from? This is kind of a theoretical question. I'm not really going to go into it, but there's other videos where they go into where that root 2 comes from and how you can derive it and stuff. But I'm not going to really go into it here. Now this over here, this Vm over root 2, this is the magnitude, right, of your phasor. This is sometimes called V effective, V with a little e under it. So let's say you have, so now let's move on to the current, right? So you got your I of t, so you got your I of t, right? This is a time varying signal, and that's going to be I m cosine omega t plus phi. So if you want what is the phasor form of this, well, it's going to be the same. It's going to be IM. So you don't want to do that. You don't want to use a root 3. You want to use root 2. Root 3 we'll get to later when we do three-phase circuits, but right, and then we put the phi over here. Okay, so that's the current. So just one thing to note here is this omega t. The omega t is going to be the same for V and for I. It's going to be the same. You have a 60 hertz system, right? So everything's going to be 60 hertz. The only thing that really changes is your theta. You've got theta over here, you got a phi over here, but your omega t remains the same. One thing I do for my equation sheets is the way I write it is this. I do V of t is equal to Vm cosine, right? And then I have this kind of, then I got the arrow, then I got V is equal to, Vm over root 2 angle theta, right? So this because sometimes you're going to get a question on the exam, and they're going to tell you, that, oh, you have some voltage source, right? And then maybe you have some impedance, right? And this voltage source, they're going to tell you, is V of t. They're going to give you the V of t of it, and they're going to tell you, maybe they'll say that this is like 3J or something like that. And you need to calculate, maybe I. Well, in this case, you're going to need to take this V of, if you want to do it the easy way, you're going to have to take this V of t, turn it into this V over here, and then do I equals V over Z, right? If you want to solve this the easy way. So you need to be able to go from this V of t to the phasor form. And this is kind of nice because you can figure out you can figure out your VM, and you make sure that you can divide by the root 2 and you don't multiply on accident or something like that. So that's what I put in my equation sheet, just so I can not make a mistake, basically. Because if you multiply by root 2 instead of dividing by root 2, you're going to make a mistake, and you might get confused because there's root 3's for three-phase power, and the root 3 sometimes you multiply it, sometimes you divide it. So just so I don't get confused and make a silly mistake on the exam, I always, I would refer back to this and just make sure it's the same, just for better human performance, right? So that's all that we're going to look at for this lecture. See you guys next time.